Hello ladies and gentlemen, welcome to Forces 2, Lesson 2.1, How do I calculate acceleration? In this lesson we're going to be walking through in our notes how to calculate acceleration using the formula final velocity minus original velocity over time. So here are your notes. It's the bottom half of your note sheet, and we're going to read the problem together. We're going to find the parts, and then we are going to solve for acceleration. So Rupert was biking down a hill at a velocity of 10 meters per second west. When he got to the bottom of the hill in 30 seconds, his velocity was 25 meters per second west. We need to calculate its acceleration. And so we need to remember what the formula is. So we do FV minus OV over T. And so we find our parts there. So I'm going to actually make it in blue, our final velocity, and then in orange there, and then our time is going to be in green. So we'll do it that way. Our final velocity is 25 meters per second. Our original velocity is 10 meters per second, and then our time was about 30 seconds. So we're going to put those in there. And so we have our final velocity, 25, minus my original of 10, divided by 30 seconds. Now I just simplify. I have my this in my brackets here. I'm going to simplify that to 25 minus 10. That's 15. That's a difference of 15 meters per second over the course of 30 seconds. And that's going to equal 0.5. And so my label for that is going to be my velocity label, and then a dash for the time. And so it's going to be 0.5, and my velocity is meters per second, and then my time was per second as well. And now I need to have the direction, which is west. The next problem here, Stuart was racing up a long hill. At the bottom of the hill, he was running at a rate of 8 meters per second west. At the top of the hill, he was running at a rate of 2 meters per second west. It took him 32 seconds to climb to the top of the hill. Our job is to figure out the acceleration or deceleration of this. And the way to identify whether or not it's deceleration or acceleration, if I'm getting faster, I'm accelerating. If I'm getting slower, I am decelerating, so I'm going to have a negative value. So I remember my formula as I see down here, final velocity minus original over time. My final velocity, I ended up at 2 meters per second west. My original was 8 meters per second west, and my time it took me to climb the hill was 32 seconds. So I'm going to put those into my formula. 2 minus 8 divided by 32 seconds. Okay, so I get that, and I end up with 2 minus 8. That's going to be a negative 6, so that tells me deceleration. And so I get negative 6 divided by 32, and so I need to calculate that. So after putting that into my calculator, I get to about a negative 0.19, and that would be meters per second, and that would again be west. And so I get a negative number. I need to remember that I put that in there. And so I got negative 1.9 meters per second west. That means that every second he was slowing down at a rate of 0.19 meters per second every second. So those are our example problems that we have, one for acceleration and one for deceleration. You should have those copied down, circling each part, putting them in the formulas, and then solving with the correct label.